Hello and welcome back to the SPRO video channel. Today we're going to be taking a look at our special order thermal cameras. They're 4 megapixel, are available in a variety of focal lengths and contain dual image fusion, meaning they will capture both a thermal image and a standard vision image from one camera. They also boast some special features such as smoking and cool behaviour detection, fire detection, temperature measurement, as well as cold and hot spot trace. There is even a flashing white light and inbuilt siren to produce a deterrent effect when an alarm is triggered. Here we can see the turret style we offer, although it is also available in a bullet housing. And you'll notice the two different lenses the camera uses, the thermal lens and the vision lens. The thermal lenses are available in 2mm, which would have a vision lens of 2mm, 3.5mm with a vision lens of 4mm, and 7mm would have a vision lens of 8mm. Since the camera has two lenses and is capturing two sets of images at once, it will occupy two channels of a recorder. But what you lose by sacrificing an additional recorder channel is more than compensated for by achieving far more accurate alarms. Let's take a look at some of the applications in which you might benefit from a thermal camera. What thermal cameras are best known for is detecting targets even when they're hiding. Here we see a typical night scene in which someone has concealed themselves in the bushes. As you can see, the footage from a standard camera makes the detection of the target virtually impossible. And as the target emerges from the bushes, the standard camera doesn't have enough time to track the target until after it's crossed the tripwire, and so doesn't trigger the alarm. But let's switch now to the thermal camera. Now, thermal cameras cannot see through solid objects, but they do make spotting targets in environments like this one and facilitating more accurate alarms a lot easier. The target's heat signature immediately gives them away and makes it obvious exactly where they're hiding. You'll also notice that in this example, the target emerges from the bushes, and when the target approaches the tripwire, they are detected long before they even get to it, meaning the alarm is triggered when the tripwire is crossed. This can set off the active deterrence features, letting us know that an alarm has been triggered, and in addition to the flickering light we can see demonstrated here, there is also a siren sound which can be activated. Let's put the thermal camera's alarm capabilities as well as their general detection capabilities to the test with a long distance example. We've covered how powerful the thermal cameras are at detecting hidden targets, but even when a target is out in the open, thermal cameras are the most accurate method of detection. It's actually even more accurate than our own impressive AI Pro technology. This is because thermal cameras are not looking for pixel changes, but heat signatures, which greatly increases the camera's effective distance. If we look at this standard recording, the target is almost lost entirely into the background. There's virtually no chance of detection taking place here. Yet if we switch to the thermal recording and take a close look, we can just about see that there is someone here approximately 100 meters away. Admittedly, it's still pretty difficult to spot them, but compared with what the standard camera could see, we have at least now made detection possible. Obviously, this example is a relatively extreme one, so let's look at another comparison at a more reasonable distance. In this standard view of the scene, the target is just about visible if you know where to look, but could easily go undetected. Whilst it isn't impossible to see the target, bear in mind just how difficult it is as we switch over to the thermal view. In stark contrast to the previous view, it's clear just how easy it is to detect the target in this environment with the thermal view. The target is easily visible due to the target's body heat being detected. It has now been made abundantly clear that there is someone walking past, compared with how the standard camera coped with the scene. Now, as promised, let's also take a look at the thermal camera's long distance alarm capabilities. And because the thermal camera is looking for heat signatures, it also helps with detecting that a target has crossed a tripwire or intrusion. Here we see an example of a tripwire being used to great effect as it detects the heat of the target's body crossing into the car park and triggering an alarm. We also see in this clip a different thermal filter being used that we've not yet seen, and it's actually just one of many. Let's cover these different filters in more detail now. The thermal cameras come with a number of different filters that you see being cycled through here. These are designed to further increase the visibility of the thermal images captured and make picking out the relevant information as easy as possible. You'll find that certain filters will work better for different environments dependent on the level of heat differential between the coldest and hottest part of the image. Let's now see how a thermal camera can be particularly useful in a comms room setting. Here we see the standard view, but if we switch to the thermal images, we can see another filter being used, the one that we found works best in this comms room environment. This is also a good place to demonstrate the camera's temperature measurement feature. In this setting, we may wish to monitor the temperature of the server to make sure it doesn't overheat. If we increase the temperature in the room, we'll see that as the server hits 38 degrees, an alarm is triggered. And this could be set to notify the necessary person that there's a potential problem. This is a great example of how thermal cameras don't have to just be looking to detect human targets. They're suitable for a variety of applications like this, where it's important to monitor the temperature of certain objects or places. But that isn't the last of the special features these cameras offer. They're also advanced enough to use their technology for both smoking detection and call detection. This makes them incredibly useful in different applications. The list is endless of places where you may wish to prohibit smoking, and the thermal cameras can even utilize their active deterrence features, the flashing light, the siren, etc., to deter those who do start smoking. This could be applied in areas from those where it is undesirable to have someone smoking, right up to areas where it would be hazardous to do so. Similarly, the cameras are capable of detecting when a phone is being used to make a call, and reacting in the same way. This would most commonly apply to petrol station applications where the use of phones are restricted, but would work wherever phone use needed to be monitored and deterred. Fire detection is yet another feature the thermal cameras utilize, and you can see just how quickly it picks it up. This is because it uses its AI to look for the specific movement and behavioural properties fire exhibits. A lot of the time, systems that claim to detect fires actually are just using temperature detection like the feature we've previously looked at. However, these cameras are detecting that it's fire based on specific attributes that fire has, like the way it moves. So as you can see, thermal cameras are useful in a number of applications, from detecting hidden targets to monitoring the temperatures of important areas, as well as being packed full of advanced features like fire detection and temperature measurement. And not forgetting making the everyday activity of providing alarm information more accurate. Thanks for watching. Please click like and subscribe so you don't miss any future videos from us here at SPRO.